Good day everyone, and welcome back to our channel. Today we'll be talking about the definition of the derivative, in which it is given by the formula the f prime of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. So this formula here is the one that all of other derivative formulas in the future will be taken from. So maybe you'll be asking, where did this formula came from? So our job this morning is to derive this formula in a simple way. I know there are some other books and some other materials, reference materials, that will give you the direct proof of this. Some of them are very complicated, others are simple, but this time we'll have this approach, a very simple approach, and this approach is graphical method. Let me start first with your background in high school geometry, in which you are very familiar with the word slope. So in geometry, you have been talking of the slope of the second line, in which you can determine the slope of the line by 2 points. So you have defined the slope in high school as y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and this one, you know that the numerator is the change in y. Okay, so that is the inclination of the line with respect to the y-axis, and the denominator is change in x, which is the inclination of the line with respect to the change of the point from one value for the x-axis to another value in the x-axis. So remember that in high school, when you are determining the slope of the line, we are talking of a second line. So a second line is a line that intersects a curve in 2 points. For example, this is a curve, so we can say that this is a second line because the intersection here are 2 points. Let's say this is point B and this is point A. Okay, and there's another case. For example, we have a curve and we have a line in which its intersection with the curve is only 1 point. So this one is what we call the tangent line, but this one is a second line. So slope here is applicable because we have 2 points. But what if we have only 1 point, in which that is the intersection of our tangent line and our curve? That's very simple. You will just find the limit of the slope. Okay? So in other words, in calculus, since we are talking of an instantaneous slope of the line to a curve, then we will take the limit of the slope formula that you have learned in high school days. So I will scroll down and we will move to the derivation of our formula. Okay, so we will start with the Cartesian plane, and in the Cartesian plane we have x and y axis, and for example we have here a function, any function. Let's say this function is y which is equal to f of x. Okay, and in this function we have a line. Okay, we'll approach this one using your background in high school. Okay, so this is our line, and notice that this line here intersect our function at 2 points. So we'll label this one as point A and point B. Okay, so that is a second line, that is not a tangent line. Okay, but this second line that intersect our curve y equals f of x will help us to determine our derivative formula. Okay, so how do we determine the coordinates of point A and point B? Because before we can find the slope of the second line, we need to have first the coordinates for point A and point B. Okay, so we'll do some broken line here from point A to the x-axis, and since this point is at the x-axis, we'll label this one as x. Okay, small letter x, and its corresponding value is, of course, if that is x, it will become f of x, or f of x. In advanced algebra, we know that f of x is also the same as y. Okay, so we have now 2 points for A. So the coordinates now of A will be x and f of x. Okay, our next job is to find the coordinates of point B. So the same process with point A, we'll drop here broken line, and this time we could not label this point as x because x is the distance here from the y-axis up to the broken line from point A. Okay, so this point here is not x. We could not label that one as x, but notice that there is a gap or a distance from the broken line of point A and the broken line that we have just drawn from point B up to the x-axis. For convenience, we will label this one as h. Some other books label that one as delta x or change in x. And since this is the distance from the y-axis up to this broken line is x, and there's another distance from this broken line up to this broken line from point B, and that is h, what do you think will be the label for this point? It's very simple. We'll add x and h. So we added x and h. So its corresponding value, the y-ordinate of point B, it could be found in the y-axis here. We could label this one correspondingly as f of x plus h. Okay, so as of this time, we have now coordinates for point B, which is x plus h, comma, f of x plus h, and the quantity of that. So now that we have our coordinates for point A and point B, we could now derive the slope of our second line. Remember, it is second line. Okay, so I will just write again here the corresponding coordinates of our point so that it will be clear for us. So point A, now we have x and f of x, and point B, we have x plus h and f of x plus h. Okay, so we will derive now our formula. So the slope of the second line is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And for convenience, I will label that one here in our point. So this will be represented by x sub 1, y sub 1, and this is x sub 2, and this is y sub 2. Okay, so going back to our derivation, y sub 2 is here. Okay, so this will become f of x plus h minus y sub 1, which is f of x, all over our x sub 2 is here. So that is x plus h minus x sub 1, which is x. Okay, and notice that in the denominator we can cancel out the positive x and the negative x. This one here, positive x and negative x, will be cancelled out. So we will be left with f of x plus h in the numerator minus f of x all over h. And this result is the slope of the second line. And remember, I said that in calculus we are interested with the slope of the tangent line. So how can we make this slope of the second line as slope of the tangent line so that it will be an instantaneous slope of the tangent line to a curve? The answer is very simple. We will find the limit of that as our h approaches 0. Okay, so this will be equal now to the limit as h approaches 0, which is our denominator, of f of x plus h minus f of x all over h. And this time, this result is the slope of the tangent line. So I would like to repeat that in calculus we're interested with the slope of the tangent line. And how do we do that? We do that by finding the limit of the given function as h approaches 0. Because if we will not find the limit, that is not applicable to our subject, because that is only applicable in plane geometry, which is the slope of a second, or in analytic geometry. So this part here is what we call the difference quotient formula. Okay, difference quotient formula is very important because all of other derivative rules in the future will be taken from this formula. And if we will scroll back to our definition here, notice that this part here is exactly the part that we have just derived. The limit as h approaches 0 of f of x plus h minus f of x is equal to h, which is by definition is equivalent to the derivative of the function. So I hope that this very simple illustration using graphical method to derive the difference quotient formula will help you. Thank you very much and see you soon.